let's get into the big topic of open source, something that we actually say at Red Hat.
This is so
we
awesome.
are an open culture that believes
actually
in
a big
importance of
piece
What is that process that a developer, or let's say
As the Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Admin Office Hours live stream. I am Andrew Sullivan, and I am not joined by Jonny today. So Jonny is unfortunately out for various reasons. He won't be back for a couple more weeks. So I am sorry to say, everyone, that you are stuck with me and me alone. So I am, however, joined by Prasanth from our OpenShift AI business unit. I got that right. You are part of the OpenShift AI BU?
Yep. You're right.
I was 99% sure, and then I had a doubt there right at the last minute. So, Prasanth, if you want to introduce yourself.
Sure. Thanks, Andrew. So I'm Prasanth. So I'm one of the technical marketing managers on the OpenShift AI BU. So what I do as a TMM, as they call it, is like I act as a technical liaison between the customers and the OpenShift AI product. So what does that mean? Like I get to wear like multiple hats. Like sometimes I'm a data scientist, sometimes I'm a software engineer. But the most important thing is like I'm a customer advocate. So I understand the customer problems or use case and say like, how can you solve that with the OpenShift AI product?
Yeah.
And also the broader Red Hat portfolio.
Yeah, tech marketing is fun, because it's if you've ever seen the movie Office Space, the guy, I deal with the customers. I feel like we do that in reverse, right? We advocate for engineering and the work of the products and everything else out to customers, but we also get to work with customers and advocate for them back into the organization. So it's a lot of fun.
Definitely. If you really love like doing multiple things, like wear a lot of different hats, but like in real world problems, then this is the way to go.
Yeah,
It's
definitely.
fun and challenging.
Definitely. I, as someone who's been doing this for, the better part of a decade at this point, it's something that I very much enjoy. So I'm not sad about it. Let's put it that way.
Yeah.
So thank you, Prasanth, and I appreciate it. We'll circle back around to the topic here in a moment, and I'm very curious to learn about today's topic. So for anybody who's listening and not watching us, or if you're watching us afterwards, so today's topic is DevOps versus MLOps, and Red Hat OpenShift AI brings them together. So this is one that I'm particularly interested in. And I feel like I say that every week, but I feel like that's also because we tend to choose topics that we're interested in when Jonny and I are scheduling these things. Right?
Yeah.
So, but I was at an IBM event last week, and it was an interesting event because there was 5 technical tracks, and it was like one of them was mainframe, one was quantum, one was cloud, one was AI, and then one was Red Hat, which I found it very interesting that the others are like very technology stack centric, and then there's just this broad Red Hat. Like,
Yeah.
So, anyways, I got to go to several of the sessions. I tended to focus mostly on the AI sessions, and just the things that are happening here are fascinating and interesting to me. And I feel like I'm constantly learning new things, which means that it's a good place to be. At least for me, I love learning new things, as most folks who have watched the stream before know. Anytime that we learn stuff, it's a good stream.
Yeah, definitely.
So, as I said before, Jonny is out for this week, and I think next week as well. I'm not quite sure when he returns. I'll have to text him because I know he is completely disconnected from work stuff right now. So I'll have to text him and check on him. Anyways, so this week, I know that this is KubeCon week, and historically we don't stream during KubeCon. So a bit of a mea culpa with Jonny being out and with my personal schedule around work travel and everything else. We haven't been on the air here. So thank you to everybody who's joining us. We do appreciate it. From me, your name just completely threw me off because I saw your chat pop up and I'm like, from me, how am I sending a message to myself? Anyways, so sorry, brain reset. I didn't want to lose basically a full month of streams due to various scheduling conflicts and stuff like that. Plus, this was when you were available, Prasanth, so it works out in the end. So this is a office hours live stream here on Red Hat live streaming, which means that we are here to answer whatever questions you happen to have in mind. So from me, I see you have a question there. We'll get to that in just a moment. So feel free to ask questions during the live stream, send them through chat, whatever platform you're watching us on. It all gets aggregated here through Restream, and we will be able to see that. Do our best to answer those questions. If we don't know the answers, normally with Jonny and I, one of us can be rambling while the other one asks somebody smarter than us what the answer might be. But if I don't know the answer today, I will take those down and we'll follow up and see if we can get an answer, an authoritative answer for next week, and then follow up during the top of mind segment. So please don't hesitate to ask questions. If you are not watching us live, so if you're watching us but not live, you can see on the screen there my email address, sully@redhat.com, SULLY. You're welcome to reach out to me at any time, or if you are on the Kubernetes Slack, you can reach out to us on the OpenShift users channel, which is a great way to reach out to us as well. And if you don't, if you send an email to Jonny and not me, like we tend to be pretty good about including the other one in the responses. So don't hesitate to reach out to Jonny as well, jonny@redhat.com. Okay. Top of mind stuff. So I really don't have a lot of top of mind stuff because I want to direct everyone over to KubeCon. KubeCon Europe is happening right now over in Paris, France. I am sad that I'm not able to go there, but I am happy for all of the folks who were able to join. Lots of stuff happening over there. This is where we're doing the official big marketing announcements around OpenShift 4.15. So if you've been looking at the Red Hat blog, you've probably seen a whole list of blog posts about 4.15 features and capabilities and all this other stuff. So 4.15 was actually released a few weeks ago. So remember, we had the What's New session back in mid-February. I believe it was February 28th was the day that 4.15 actually shipped and went out the door. And then we've just been holding off for KubeCon before the marketing folks make a big deal out of it and you see it all over the headlines and everything else. So we will have a series of topics coming up that talks about OpenShift 4.15 features that are important and relevant for administrators, just like we always do with every one of the releases. So kind of stay tuned for those. Keep an eye on the schedule. I think we have staged a stream for next week, but I want to say that one is going to get pushed because of scheduling conflicts with our guest. So just keep that in mind, but I am planning to still stream. It'll probably be just me. I'm sorry to disappoint anyone, but we'll be talking about some 4.15 stuff. So I'm looking forward to that one. I'm hoping I can make it into a technical session. Not that today won't be a technical session, but I want to be hands-on with 4.15 and showing some things. All right. From me, is there a way to expose non-standard ports like a database port to the internet via ingress? Not with the default OpenShift ingress. So OpenShift ingress focuses on HTTP protocol with ports 80 and 443 because it's HA proxy on the back end. You could deploy use another ingress from a partner or something like that. Use F5, use Citrix. Those are the two that come to mind. I think HA proxy themselves have an operator that you can deploy into the cluster and do it that way. But yeah, OpenShift and the default OpenShift ingress uses just HTTP on ports 80 and 443. So you would want to use something like a Metal LB or if you're in a hyperscaler, whatever the load balancer provider is there, to create a service of type load balancer, or you would want to use a host port / node port, which you can do that. But I don't know. I tend to shy away from the host ports and node ports because there's a limited number of them, and two, it actually opens up that port on all of the nodes in the cluster. And you don't know where in the cluster the pod or pods may be. So you need to have something, a load balancer or something like that outside of the cluster that's pointing at all of the nodes on that specific port so that they can pick up and be able to access that application. So it's not necessarily a straightforward thing. You either have to know the node that the pod is on so you can address the port on that specific host IP, or something like a load balancer to abstract it. But thank you for the question. All right, I've rambled for 11 minutes now. So Prasanth, please. So today's topic is, I think this might be one of the first AI, MLOps centric streams that we've done. Excuse me. So I want to start off by kind of introducing some of the terms, some of the things that we'll be talking about and stuff like that. And, I kind of want to let you just go and do your thing. And I'll ask, it's as Jonny and I love to say, right, the role that I was born to play, right, dumb guy.
Okay.
I'll ask as many questions as I can.
Good. Sounds good. Yeah. So that's how I start to go at a very, very high level and try to explain the terms, so that users get the sound understanding there. So today, as Andrew said, today's topic is about DevOps versus MLOps. So I know now the buzz is around AI, machine learning, MLOps. Before we even go down that route, let me go to the other side, saying DevOps. So everybody's familiar with DevOps. Now it has multiple phases, tools, frameworks, and so many things. But let's go one step higher. So what's DevOps? You're essentially talking about smoothing out the collaboration between two teams, the development and the operations. It's as simple as that. Now, if you take that to the AI machine learning world, I can say it's okay. Now we have a machine learning team and the operations team. So now if somebody asks, are they this? Oh, sorry, go ahead.
No, to be clear, it's not, and my brain always wants to say MLOps is, AI or machine learning doing operations. And that's not necessarily the case.
No.
We're not using some sort of AI to, Skynet, replacement for administrators or operations teams.
So, so there are two ways to use AI machine learning, right? One, let's say it could be inbuilt into a product, or it could be a product that allows you to build that product.
Yeah.
So here, when you say about DevOps or MLOps, you're actually talking about the people, the process, and everything that happens around it. How can you collaborate and come together so that everything falls into place, from design to development all the way to deploying it and managing it. So that's how that's what MLOps is about. So now within this, you could have AI machine learning helping the administrator, but that would be an intelligent application by itself. So that could be anything. But when we talk about DevOps versus MLOps, we're talking about the process size and the whole end-to-end process and collaboration that happens.
Mm-hmm.
So
can I tangent you again for a moment?
Yeah.
So I think we have started to use the terms AI, artificial intelligence, and ML, machine learning, interchangeably.
Mm-hmm.
I know that technically there are differences, but should we just assume that when we talk about AI ML, we're just using that interchangeably to basically mean one of two or three different things. So one being so as you said, an intelligent application, an application that has some sort of AI ML augmentation, which I know that's a loaded word as well. To help it function better or help you, the user of it do something better. Two is, and I think this is where OpenShift AI fits in, it's a platform to use for building things like models.
Yep.
And models are for lack of a better term, they are the intelligence behind those AI ML applications. Mm-hmm. And then I think three is your applications using your models in order to enhance whatever your application, organization, business is doing.
Yep. Yeah. In a real world, these fancy machine learning models, there's no point in self-existing, they don't serve any purpose. unless they are actually like integrated into an existing technology stack, like your existing application, so forth. Like, say you have an application that predicts what the weather is, unless your existing weather app uses this, there's no point in having that machine learning model. So in a pure sense, we are talking about like a unified ops, or like we have the traditional application, but it's also using the machine learning functionalities, which makes it an intelligent application or like system as together. So this is where I would differentiate between AI and machine learning. So let's say and we even have, for users that are interested, we have a video like in YouTube, just search for OpenShift AI versus machine learning. There's a video that explains this exactly, and I'll just give you a gist of it. So all of us have like a streaming service, like where we watch movies and so forth. Now, let's say you have a bunch of movies. The first time you log in, you say okay, I'm seeing a bunch of movies. Okay, let me say I give a thumbs up for this, the other two not so, and then you say okay, thumbs up for the rest of the choices. Now, the system or that particular service, like the streaming service, they take the user input and says now I want to understand how this user is providing the rating. So it's trying to learn what the user is providing. So this learning mechanism is called machine learning. Now, once it understands how the user, what kind of movies or a series that the user likes, it has understood the user, which means it has learned that particular user. Now, it doesn't stay there. The user's choice could keep changing every single day. Now, the broader AI system would be something which continuously evolves or tunes its learning. Mm-hmm. So that whole thing is called an AI system. So this could be anywhere, any of those products that you have, like Alexa or things like that. So it tunes it tunes its system or knowledge base based on how the user input changes, right? So we have the whole AI system, and machine learning is this part where it's trying to learn how the user is kind of changing his choices.
Is that the same as a context aware engine versus retraining the model? Mm-hmm. And so, because I think there's two different things, right? So one is, so I take a set of data and I input it, and it has mm-hmm. things like, when users that, match Andrew's profile make these selections, mm-hmm. they tend to also like these things.
Yep.
And so that's the initial model. And then the context aware thing is oh, Andrew is thumb up or thumb downing these things, and therefore it skews my personal thing. And maybe that big data set eventually gets fed back in and it retrains, the underlying model so that without that context aware stuff, it starts giving me those things.
Exactly, right? So it understands the context. Now it's adjusting itself. So that's the intelligent part. So that's what the whole AI system does it. So nobody's prescribing it rules. In the past, we had a deterministic system says hey, if user likes X, Y, and Z, do this. But now it's kind of adapting itself to the environment and relearning and understanding the context and evolving itself. So, that's the whole part of the AI system being intelligent. Yeah.
And so I'm gonna interrupt you real quick to answer from me's question here. So disaster recovery HA setups I've seen involve 3 sites. Is there an option for only 2 sites? And then Metro DR, regional DR. So OpenShift, a single OpenShift cluster requires at least 3 nodes for HA of the control plane. So in this instance, I want to say, and somebody just called me out a couple of weeks ago, and I was delivering a session, and they're like, we should really standardize the language that we use for high availability versus disaster recovery. So high availability here is referring to within the same cluster, within the same set of resources, ensuring that workload continues to be available. So if I lose a single control plane node, things continue to function. Whereas disaster recovery is the entire cluster is offline. How do I recover, the entire set of workloads somewhere else? So HA in this instance would be, how can I protect, at least the way I'm interpreting it is, how can I protect a cluster that is spanning two sites or using two sites? So spanning two sites, really not any great options because 3 nodes for control plane HA. So that means that one site is always going to have the majority of nodes, 2 in that case. So if that site were to fail, then the surviving site would be read-only until one of the control plane nodes comes back. So really the way I approach it is having 2 separate clusters, one at each of those 2 sites, and then you manage the workload and where it goes inside of there. So you could use something like, ODF's Metro DR, ODF Regional DR in order to protect that data. Various storage partners also have solutions there. NetApp comes to mind. Dell EMC comes to mind. I know HPE also does some things there. Portworx, there's a whole bunch of them. A lot of them support various replication. Usually the hard part is, how do I reintroduce? So my primary site has failed. How do I reintroduce the workload at the secondary site or the recovery site? Historically, and if Jonny were here, he would be banging the GitOps gong, because GitOps is a great way because, here's my workload. I'm describing it in a declarative manner. And if something happens to that site, I just use Argo CD to redeploy everything at the recovery site. But you could also do things like, and there's several blog posts of this on the Red Hat blog, of use like a global load balancer. So I have the application deployed in both sites. It's doing some sort of replication between them. I use a global load balancer so that traffic coming in when the site fails is just automatically redirected to the other site. And then Babuni asks, so this is a question for you, Prasanth.
Yeah.
So to learn OpenShift AI/MLOps, what are the prerequisite technologies to complete first?
So let me go back. And so to understand AI ML ops, you need to focus on 3 main pillars. The first is the model development, or called as model training, and then model serving. So that is once you train the machine learning model, how do you take it and deploy it so that you can start running inference against it? And then the third part is the model monitoring. So that's where okay, you've got the model, it's running in production, but you still want to monitor it or manage it. And since you want to make sure the model does what it is supposed to do, so you kind of focus on those 3 pillars. And that's the breadth of it. Now, if you go into the depth, model training, I would say start looking into some of the popular frameworks TensorFlow, PyTorch, and so forth. And within that, you want to understand the generic way in models are trained, what kind of algorithms are used. So I would say there are classical algorithms like regressions, classification, and going all the way to deep learning, neural network models, and now the latest being large language models like ChatGPT. So how they actually function. So you don't have to go into the details of it, but how do you train the models, use the models, and so forth.
And that's the realm of a data scientist primarily.
Yeah. And model serving. So once you have, depending on the framework that you see, let's assume that you're using TensorFlow. Each of these frameworks have a way of exposing, downloading the models and exposing it in the form of an API. So you could use a container platform like OpenShift, where you just containerize that particular model, expose an API to it, or use frameworks like what OpenShift AI uses underneath, model mesh, K-serve, because they take out the burden of you dealing with the different frameworks. How do you wrap it around exposing it as an API? So those would be suggestions for under model serving. So with model monitoring, so you got to understand the concept of a drift. So when we are training a machine learning model, we are actually focusing on the data and the pattern that could produce the data. So unlike the traditional development path where like you're just monitoring the application for performance or like security and so forth, the concern here would be like, has the data changed? Because the model is probably like good, like there's nothing wrong with it, but the data that it was trained completely changed. This could happen a lot. So you want to keep an eye on it. So you want to understand like, how do I check for like model drift, and like what are the different frameworks and tools that can actually do it.
Yeah.
And when you want to put together all the three, you definitely want to understand about like pipelines, because these three steps, like you can do it manually, but if you have to do it all over and over again, like automation is the way. And so you got to understand about like pipelines.
Sorry, I'm watching myself on the screen and the dog stretched, so you can see the dog's paw just above my name tag here. I'm easily distracted.
Yeah.
So I think it's also, I want to point out that you don't have to be a data scientist
Yeah.
to utilize, to take advantage of, all of these things. And, I think ChatGPT, and all of these other things are a perfect example of that, of
Yeah.
somebody else is building that model and maintaining that model. And effectively, we are taking advantage of the model serving aspect,
Yeah.
which is, my my user clicked on this button in the application and it sends something over to the model serving apparatus, and
Yeah.
it does what it does with that input and gives you back some output that you then use somehow in your application.
Yeah.
In the case of ChatGPT, right, it's taking my spoken words language and interpreting that, and then using what is it, real-time augmentation, RAG. No, I don't remember what RAG stands for. Real-time augmented generation,
Mm-hmm.
where
Yeah.
it will, in real time, it will reach out and incorporate internet search results or various other things to craft a response back to me.
Yeah.
But yeah, you don't have to be a data scientist to be deeply involved with AI/ML.
Yeah, and sorry, like that's retrieval augmented generation. But yeah,
Yeah.
I mean, as Sandra said, like, see, don't get bogged down by that. Like, there's a lot of math behind AI machine learning, but we've come so far that you really don't have to worry about the math and machine learning. I mean, you still have to, but there are ways for you to like extract the output without worrying about like how it was implemented, what's the math behind it. So as you can see, like if you had to go back a decade, like all the machine learning models, you have to understand the details, because when you have a machine learning model, like you basically, it was a pattern. When I say a pattern, it's a mathematical formula. And to use that mathematical formula, you need to understand what the formula is about. Like, how do you provide the inputs? Like, what format do I provide the inputs? How do I wrap this into an application and so forth? But you don't have to worry about that now. Like, you've got like tons and tons of like frameworks, tools, and libraries that you just simply pass in the data. And OpenShift AI, like that's what it basically covers end to end. It's so easy for an end user to develop an intelligent application without having to worry about all the nitty-gritty details underneath.
Mm-hmm. So I think that answers we eventually got to the answer to Babooni's question, I think there.
Yeah.
We just sidebarred to
Yeah.
answer other questions that were coming from me, which is things that we would have addressed eventually in the normal. My questions were things that I think we would have addressed normally throughout the conversation today anyway. So, Babooni, if that didn't help or didn't answer your question completely, just let us know in the chat. So jumping back, before I interrupted you for questions, Prasanth. So DevOps, MLOps. So you were talking about, sort of level setting for DevOps and MLOps and what that means.
Yeah. So, like anytime you talk about these two concepts, like there's always like the question is like, are they the same or are they different? Because they have ops in their name. So are they the same or not? So and there are like two different worlds, right? Like we're talking about a development team, like a machine learning team. Yes, the workflow's different, like how they come up with the model or develop the model versus a traditional application. Those are all different. But if you look at it conceptually, they are actually the same. So, and I can actually say this because I've been in the software engineering world and a data scientist world. So it's if you have a data scientist or like a software engineer and you tell them like they're the same, like there's nothing to be offended about it, like because conceptually they're the same, because you are trying to like seamlessly uh, collaborate between two teams, and what's the process you follow, like it's kind of like interchangeable. So, well, now there might be argument saying like, well, it's not just two teams. Like, okay, what about data and ML team, like dev and ops team? Now it becomes data ML dev ops team. So, there are multiple ways to put this,
Don't forget
but
security in there.
yeah, I know. It's like there are so many ways to put this, but if you look at the different stages involved in DevOps, and also look at what ML ops involves, you can clearly see that, oh, they're pretty much the same. There are different tools, but they're pretty much the same. So I can probably go a little bit into the details. So let's start with.
Well, so my high level recap there is, so DevOps is developer and application teams working together with operations teams for, at the platform level to help the application stay available, to scale correctly, to, do the things that it needs to do. MLOps is effectively the same thing, but instead of an application team, it's more or less a data science team.
Yep. Yeah, and the definition is kind of like the boundaries thin nowadays. Like it could be a data scientist, machine learning engineer, like statisticians, or anybody who develop any team that comes out with a machine learning model. So yeah.
Got it. Okay, thank you. That's helpful.
Yeah. Good. So let's dive a little bit deeper. Now we made it clear, okay, it's between teams. So with DevOps, like traditionally it involves like you start with the core, then go to the build phase, then you're testing the builds and like making sure placing the quality controller out, then you're releasing it. That's like where the CI/CD comes in place, and then you're deploying it, and then you're monitoring it, and that whole infinity loop kind of like continues, right? So let's dissect it one step at a time. Now, with DevOps and MLOps, let's start with coding. So coding, like the focus is on like writing the code and like version control. So with DevOps, you call it as development, and the ML ops world, we say like it's training. So it's, if you call it model development, nobody's going to come after you because it's eventually the same. You're all writing codes either to come up with the traditional app or like the model. So with DevOps, like when you're coding, like how do you do that? You start with the design and then you start to write the code. You choose a language, and like so the byproduct is the code itself. But this is where like it slightly differs in the MLOps world, where like you start with the data and you're trying to understand like what is the pattern that could have led to this data. So you're eventually trying to discover the pattern. So even though you're writing a piece of code that could tell you what this pattern is, the focus here is not on the code itself. You need that, but the actual focus is the data and the model, or like the pattern that comes out of it. And often a lot of people get confused, like, what is a machine learning model? Like everybody says it's a ML model. Well, it's just like a binary dump, period. Like it has details about like what that particular mathematical formula is. And the simplest example I could give is like a linear regression. So I'm sure like a lot of the people, like you know what's the equation of a straight line is. So y is equal to mx plus b. Now, the model stores this in a file, and it gives values to the parameters, the slope, and the intercept. Now that is a very, very simple model. Now, when you consider like the models that we have now, like ChatGPT, consider instead of having like 2 parameters, you have 1 billion parameters.
Yeah.
And that's really complex. So,
or more.
Yeah. It's growing every single day. So that's where now you understand the coding. Conceptually, it's the same. You're writing a piece of code to kind of achieve a functionality. So you're writing a piece of code to kind of understand the pattern. So the byproduct here is the code itself, but the byproduct here is like the data. I mean, we have the input data. So we have the byproduct is the data and the model or the pattern.
Yeah.
So that's like step 1, right? Like, so we have the code, we understood what the app is, or like what the model is. So everything is ready. So what's the next step? Now we have to make sure it's in a format that's ready for use by the customer or the user. In a typical DevOps world, like, what do? We compile it. So what does that mean? We're just putting the code or like the different parts of the code in the correct order so that, at the end of the output process, like we have the executable, or it's in a format that can be readily consumed by the user. So which means I can use the code now. Now, the same thing happens on the MLOps world, where like you have this pattern locally, either in memory or like on your local disk. Now you just want to dump it in a format that can be consumed by the user. And most often, like the frameworks that you use, like TensorFlow or PyTorch, allow you to do this. So it's automated there. Like just like how you would have like Maven, Make, or Ant, or anything in your DevOps world, we have libraries and tools that exist within the frameworks that allow you to output a build. We don't call it as a build, but we just call it as a model. So there are still like tools and frameworks that allow you to like get to this stage. So we started with the
never thought of it that way.
Huh?
I've never thought of it that way, as being, basically very, very similar things,
Yeah.
with different language.
Yep. So if you let's put them together. Like, so we started with the requirement, have a code. Now we had the same, like we wanted to find a pattern, we had a model. Now we went to the build stage where, okay, I'm converting this into a format that's usable by the customer or the user. It's plain as simple as that. And the next stage, what happens in a DevOps world, like we test it. We need to make sure it works. The same thing in MLOps world. I know the data scientist said like the model is super good. It's so accurate, but we need to test it, period. So that's where you validate the model. And, like, just like here, there might be multiple teams involved, like a QE team, or, like have like the developers do like unit test, integration test, black box test. There's so many ways to do it. Just like that, in the MLOps world, like there's like so many ways to test the specific model. Like you can do cross validation. The technique is different, but the concept is the same. You want to make sure it works. That's it. And once that is done, this is where like you move to the next boundary. You hand it over to the operations team. Now, typically, before all these DevOps, MLOps concept, what did we do? Like, we had to give it to another team, like the operations team, say like, hey, just throw it over the fence, let them deal with it. But now, when we are like passing it over, we talk about continuous integration, continuous deployment, right? So the same thing applies over in the MLOps world, but we call it as pipelines. And see, even in the DevOps world, like if you're using OpenShift, you're using OpenShift pipelines. Simple.
I was just going to ask, is that like terminology overlap, or are we literally referring to like OpenShift pipelines, functionality?
So it's kind of like, so traditionally when they were trying to differentiate between the development and machine learning, they say like, okay, developing a traditional application is kind of like a monolithic. It's like a single step. But with machine learning, it's a pipeline of steps. So I would say like it's not wrong to call it as like CI/CD or pipelines, or a workflow, because you're talking about like seamlessly connecting the different pieces so that like it can go into or it can continue to run in an automated fashion. So that's like the CI/CD. So you're using like say OpenShift pipelines, and for you could also top it up with like a CD framework like GitOps. You try to handle the infrastructure as a code and a piece like that. And the same thing is possible on the MLOps side, because now you're using pipelines. That's we have like data science pipelines that's based on Tecton CI/CD engine, which runs the AI ML workflows. So regardless of whether it's a traditional application workload or an AI ML workload, like workflow, we're kind of using pipelines to kind of like automate it.
Got it. But Babuni asked a question here about the OpenShift AI Administrator course, AI 263. I don't know if you know off the top of your head if that's available or not.
No, not that I know of, but I could check about that.
Okay.
Yeah.
I'm sure GLS is working on a lot of these things. They're very busy these days. So
yeah, I'm connected with the enablement. So I'm not familiar with the name, but I'm positive that GLS is working on a course right now that's on OpenShift administration. But I can't say if that's AI 262 or 263, but it's definitely coming out, and keep your eyes open. Yeah, it's definitely coming out.
Yeah.
Okay. So yeah, I mean, going back to like the different stages, right? Like now you see like, okay, we've produced the app or the model, and then you're like handing it over to the other team. So that team needs to kind of like seamlessly handle these models, or like the models. So what happens in a DevOps space, you have a code or build that knows it's been tested, it works. Now you want to turn that into a microservice, or like containerize it, like run it on top of your platform. So all of this is done, like let's say you're using OpenShift, like everything is done for you. Like you can use like source to image, like automatically convert that, like turn it into a microservice, like have an API endpoint. Now the same thing happens with OpenShift AI. So we have like model serving frameworks where you just point to the model. It's so easy that when the model is stored in an external object store, you just simply point to it, and everything happens under the hood. Like it knows, it picks up the model, like embeds that into a container, depending on how you would want to tie it to the resources underneath. But in all sense, like it picks the model, like puts it in a container, gives you the API. So if you look at it between the two worlds, it's the same. You have a usable product, you're converting that into a microservice with an API endpoint. Now,
and we refer to that generally as model serving.
Model serving, exactly. Now, the last part is like, okay, I have a product that's running in production, but you need to monitor it. You need to make sure it does what it is supposed to do. That's exactly what you do with DevOps as well as MLOps. So, and in the OpenShift world, like both kind of use like the Prometheus, like the OpenShift container platform monitoring that's based on Prometheus under the hood. But from a user perspective, you're simply monitoring, is the product doing the right thing? If not, then continue running the loop. You go back to the code, change the code, like retrain it, and so forth.
Yep. Yeah. So Agi John here asks, which tools and topics do you recommend to a junior Linux administrator who wants to be a DevOps engineer? I don't know if you have any thoughts or input on that, Prasanth. I'm happy to do my brain dump on that.
Yeah, I mean, you could do. I mean, like drawing the parallel from an ML ops world, like like learning about CI/CDs, like OpenShift pipelines, that's what immediately comes to my mind. So yeah, but I would let you go into the details if you have.
Yeah. DevOps is sometimes I and somebody's going to cringe when I say this. Sometimes in my head, I equate it to the quote unquote full stack developer, right? Because you kind of want to have knowledge of every aspect of the application and the platform to varying degrees. So that might mean, understanding RHEL, understanding OpenShift, understanding components of OpenShift, understanding application pieces and all that, depending on where your specific role is and stuff like that. Could be heavy on an automation focus. Of course, within the Red Hat portfolio, that's oftentimes Ansible and stuff like that. But broadly speaking, I would say, you want to have an understanding of how development happens, if that makes sense. So you don't necessarily need to know like C or Python or Java or something like that, but rather it's, okay, my developers are writing code. What do they do with that code? The so-called inner loop activities. How do they, compile and test that code? How do they, do after they push that code into the repository? What happens with it? What triggers the build process, pipelines? What are all the pieces inside of there? All that. At the platform level, it's understanding things that affect the application and it being, the application doing what the application does. So maybe that's, how do I do auto scaling? How do I do resource management? How do I do, custom resource management? So think GPUs. It's hard to be precise, or it's hard to be concise, I guess, terse, because it's a huge, broad swath of things in my perspective. But I'll say that this is an area where I wish Jonny was here, because Jonny is much better at describing these things than I am, because he's done a lot more of it than I did. The last time I was an active administrator at the lower levels was when DevOps was still in its I'll say toddler years. So it wasn't in its infancy.
Yeah, and then to add that, like at least from my personal experience, I focused a lot on like testing the product because I was in a QE team, but testing the product and knowing how it functions, and also like how the product is used. That kind of wraps like the whole infinity loop, right? Like you're talking about, okay, now I know like how the product is functions, like what are the inputs, the outputs, and like what needs to be done. So when you're talking about like the continuous integration, you write tests, like you kind of like automate that whole part. And once it goes into the production, you want to understand like what does it really mean when it goes to production? Like how is the software going to be used? Because now, apart from like the inputs and outputs, you worry a lot about as Andrew said, like the scale, like the availability, and like all sorts of bells and whistles, like the security, and also like what happens in the production, like does it break down, and what happens if it breaks down, right? Like then you kind of like hand it over to the dev, and if you want to fix it yourself, like it's good, but that's not necessarily required for the DevOps engineer. That's purely for the developer. But for you to like understand like why it failed, and to kind of like know that it failed and like passed over, that's what is important here.
So I want to hijack your conversation again for a moment, Prasanth.
Yeah.
So OpenShift AI. I want to ask, and this is maybe a silly question, like, what is OpenShift AI?
Okay. Now, so OpenShift AI is an MLOps platform. So I would go a little bit beyond that, because I would say it's a unified development and ops platform. So, because as I said earlier, in a true sense, you're not just developing the model, you want to use it. Mm-hmm. So since like OpenShift AI is on top of OpenShift, we are kind of bringing both the worlds together. So your existing stack or applications are running on OpenShift. Now you develop the intelligence part on top of OpenShift AI, like, and also like bring both of them together, like put it into operations and everything that goes along with it. So I would say it's an ML ops platform. and also a unified platform that brings together the traditional app development and machine learning development.
Yeah. And so Pradeep asked a question here of, does OpenShift AI have generic ready-made models pre-baked into it for immediate usage? And I think the answer to that is no.
Yeah, the answer to that is no. So we do not provide any models. But having said that, like there's tons and tons of like open source models. You can just go to like Hugging Face or like Kaggle. I mean, there are models that works, and like you can immediately plug them in, and that'll work.
Yeah. And the way I would describe that is, so if I install OpenShift, right, OpenShift doesn't supply applications out of the box, right? You can go to any one of probably a million different places and download container images and applications and deploy them to OpenShift. OpenShift just provides the platform. So OpenShift AI is a platform for doing MLOps on top of OpenShift. So it has features and functions, for and tools for data scientists who are, writing, or building models, I should say. It has tools, features, functions for model serving, and then the underlying OpenShift it's running on has the ability to host and run the application. Sorry, the dogs just got up. There's lots of shaking and collars and stuff, and so I don't know how noisy it is on my side. Is that accurate, Prasanth?
Yeah, that's definitely accurate. And like, because as I said, like the models have come up so far. Like a lot of the examples that you would find are so accurate in the sense like you grab the data, and usually like when somebody publishes a model, like it's open source, like they publish it along with the data that was used. You could start with the very simple data that they had, and it'll work right off the bat because that model simply was trained for that data, right? So as long as you don't tinker with that, like it should work out of the box. And even if you want to pass in new data, just look at the example that comes with it, like the same format it was, and then you should be able to work off with that. Yeah.
Yeah, and I know. So this is yet another of Andrew's tangents. I know there are some models that it has like a base level of training.
Mm-hmm.
So I take a massive data set and train a model off of that, and then I can refine that model based off of an additional specific user set. So there is the I don't know, the Andrew model, and it was built off of inputs from me specifically, and then it's okay, now I have that and I want to input additional data for Andrew's dogs, or Andrew's role at Red Hat, and Andrew's ability to cook, or whatever, right? And it further refines it into these things, without necessarily having to do a full retrain of that model. So I think we're starting to see more of that come about.
Yeah.
And I think that's another area where OpenShift AI can be beneficial because it gives you all of those tools in one place.
Yeah, definitely. So what Andrew was talking about is like, like all these large language, it doesn't have to be the large language models. I mean, there are like smaller ones in that category. So these models have been pre-built. Let's say, let me put it that way. So they've been pre-built for a certain purpose. Let's say you take any natural language processing models like Llama 2 from Hugging Face. So these models, they've already been trained on a large data that could be like the English language, like the dictionary, like Wikipedia, WordPress, and so forth. Now, the model understands English language so well. So it understands how the sentences are put together, like how do words appear, like, and so forth. Now you can take this model and forget about like this whole part where like you don't have to make it understand English language. That's already done for that model. Now you can take that and say like, now let me give you an English sentence and you tell me if it sounds positive or negative. Now that's a much more narrower use case, which you can just which what they call it as fine tune this existing model. So that'll definitely work. So in all sense, like you are kind of like being more efficient here because you don't have to retrain the whole model again. So, and
it's like teaching it an accent. you know, because there's English, you know, using words, stringing them together in a sentence, and then there's like I live in North Carolina, so there's Southern English, which you know people know is a distinct dialect. You know, same thing for Northeast or you know West Coast or you know there's or you know Texas. Texas has their own accent. You know, so I wish Jonny were here. I'd be poking fun at him right now because he you know he's in Texas. So I like to think of the fine tuning as you know using your example there of you know if the model knows English, fine tuning teaches it different dialects or different accents in order to be more appropriate and usable for my specific use case.
Yep. And just like the other suggestion, like there are tons of open source models that already do this, so you can just go download them, access them, and try it out.
So I guess high level, you know, pulling back up a little bit. So OpenShift AI is not necessarily or is not a an AI application itself, right? It is a platform for using or building and using models, although you don't have to build it if you don't want to. And you don't have to use OpenShift AI for things like model serving. Of course, we would love if you did that with it, but you don't have to. And I know that there's, I know there are other components, other pieces. Anything that you care to highlight?
Yeah. So let me look at the. I know like there are tons and tons of pieces. Like for example, like if you're really interested, like distributed training, because now you're talking about like large models, like pretty like compute intensive models and workloads. We have like frameworks that allow you to do distributed training, and then we have to like for monitoring, we have out of the box performance metrics and like ops metrics, and not just that. Like if you're going where like different use cases, like if you're going to build a model elsewhere but want to bring the model into the MLOps platform and so like OpenShift AI to serve it, that's possible. And you can also take advantage of like everything that comes with OpenShift. For example, like you can use GitOps to kind of like push the models to like multiple edge use cases, like multiple edge devices. So there are tons of options to do that. And not just these. Now, OpenShift AI provides a strong foundational platform, but the benefit of with Red Hat is like, I mean, we have a strong partner ecosystem, and you can leverage all the additional tools. For example, like if you're having like an NVIDIA GPU, you can also like couple it with like optimization libraries that come with it. And the default model serving framework that we use is OpenVINO, and like we have like if you're using like Intel accelerators, and then you can also use the optimization libraries. So in all sense, like users are not tied to a specific vendor or like set of tools. Think of this as like a DIY workshop. Like you can just bring in your own tools, like extend the capabilities, and like the possibilities are endless here.
So I don't want to put you on the spot. I think you said before we started that you have a cluster available, an instance available.
Yep.
In the last 10 or 15 minutes, you know, would you be able to do like an overview or showcase what OpenShift virtualization? I was just having a conversation about OpenShift virtualization before the stream. So OpenShift AI. So from our audience, you know, probably another 10 or 15 minutes. So if you have any questions, go ahead and submit those over. We'll do our best to answer them. And then, of course, as Prasanth is going through, ask away. Love to hear your questions. Again, if you're not watching us live, if you're listening to us or anything like that, feel free to reach out. You can reach me, Sully at redhat.com, SULLY at redhat.com. You know, I found that because I've seen, you know, OpenShift AI a few times here recently. So I find that it helps to connect dots for people of what all it looks like and how everything fits together. You know, when we start to see what it looks like.
I'm still trying to like share the screen just to say.
No worries. Here, I'll turn that. Oh, there we go. Just as I went to turn it off is when it popped in.
Okay. So before I go into the product itself, I just wanted to show like a slide, like the architecture. So, as I said earlier in the call, like you want to look at it like 3 pillars, like the model development or
You might need to
training.
put that in presentation mode.
Okay. How about now?
Yep.
Perfect. So yeah, I mean, like you have like a dashboard that brings the user into like the actual product itself and different administrative features, like how you control things around. Underneath, we are looking at 3 main pillars, like the model training, the serving, and the monitoring. And here, like some of like the different features that are available. And what we call as workbenches is what allows user to kind of put together their like project. Think of this kind of like synonymous with the Red Hat code ready workspaces, because with data science projects, you're like choosing an ID like Jupyter notebooks, and then like choosing your frameworks, like and then like choosing your CPU memory requirements, and you can add on like accelerators if you want. And then, like as I said, like you can choose a notebook image that comes with the product, or you can create like custom notebook images. And as the distributed workloads, we have Kubernetes, Codeflare, and we have data science pipelines that kind of like helps you automate the end-to-end workflows. For model serving, we have the K-serve and model mesh. So there are like 2 options when you're doing model serving. Let's say you have a bunch of like tiny models, not necessarily tiny, but like small, like classic machine learning models. So you can just group them and like tie them to a single resource like a GPU. So that's possible. But if you want to like exclusively tie, like say if you're working on a like a large language model, it's like much similar like ChatGPT or like Llama 2, you want to tie them to one single resource like a GPU, that's also possible. Now, serving runtimes, the product comes with like OpenVINO and then KaiKit. So OpenVINO, it allows you to like serve the models, like how I mentioned before. Like once the model is in an object store, like you just simply point to it picks it up, like embeds that into the container, like gives you an API so that all the inference is taken care from that. And KaiKit, that's more text generation inference service. That's more specific for large language models like Llama 2, because they're heavy, and like they kind of like specialized handling in terms of wrapping the data and the model itself.
Yeah, need a lot of inputs. Yep.
What's that?
Just need a lot of inputs. So that's why
Yep.
there's special serving runtimes for like an LLM.
Yep. And if you want to go the route of like having a custom model serving environment, like yes, you can plug in like Triton. That's from NVIDIA. And for model monitoring, we have like different out-of-the-box performance metrics that's coming up. And all of these are like tied to an object store. And this could be a Ceph storage or like a local MinIO object store, or it could be like an AWS S3 bucket. But all of them are based on like S3 protocol. Now, as I mentioned, like you could still use everything that comes with OpenShift underneath, like use GitOps, data science pipelines. They use OpenShift pipelines under the hood, like K-serve, use like serverless and service mesh, and then the model monitoring uses Prometheus. Now, let me go into the product itself so that you get a view of the product. So this is the dashboard that a user would typically come into. So, and I have like some projects already created. So if user wants to create one, like you simply like create a data science project, think of it like your own personal workspace. And once we do that, anything that's been created in OpenShift AI, it's essentially like an OpenShift resource. And the way you would track it down is simply using the resource name. Let's say, for example, I say like it's my project, and you see like it automatically comes up with that project, or like you could just give it another name. Now,
which is essentially a label associated with all of those Kubernetes objects. Yeah.
Yep, exactly. Now, once the project is created, it'll take you into this space where you can create workbenches, cluster storage, data connections, pipelines, and model serving. So workbenches, it's something like the dev spaces. So you can, when you create a workbench, it says like select your notebook image. And the reason you need this is like these are like pre-built images that come with the product. And say like you want to use like PyTorch, and you go to the package information, it already has other libraries you would eventually need when you're working with the PyTorch framework. And that varies depending on like which one you choose.
Yeah.
And once
So
you
this
choose,
is so the workbenches are essentially for a data scientist, the specific environment that they're going to use to effectively train the model.
Yep, exactly.
So it's, I want to use, PyTorch or to create workbooks. Okay, so I'm going to give you effectively a pod that has that deployed inside of there, and I think the deployment size has like how much CPU, how much memory. You can
Exactly.
allocate GPUs
Yeah.
and all of that. And then I think if I remember correctly, it's the project storage or the project data sources get brought in. It's you can almost think of it like a PVC, but it's not necessarily a PVC.
Yeah.
So that way it has access to all of the things that it needs. So you're sort of
Yep.
piecing together all of the components that you need to build a model at this point.
Yep, exactly. So yeah, so when you can tie it to like the different storage, like the persistent volumes, the object store where the model will eventually land. And one of the advantages here is like, let's say I create a small container size and I'm trying my development. So when you click that, so this is where you go into like a Jupyter interface. Now, let's say I'm trying out the model and I'm running it, but I see that my infrastructure is not enough. Then I can always come back and edit the workbench and say like, let me move to a much larger infrastructure, or like let me add a couple of more GPUs. So all of this is so easy, like so you don't have to like worry about like maintaining the infrastructure, like how you tie it to this. So it happens at the click of a button. So now the users can just focus on training the model.
Yeah,
And
you don't have your data scientists going in and like terminating pods and then restarting them with different resource requests and all of that other stuff. Yeah.
Yep, exactly. And the big advantage of it is like reproducibility. Like your teams can collaborate here, like everything is shared. So that it works. Yeah. So this is where you would do like your development. Like let's say here, I have a notebook. This is Python based. So you install any additional dependencies. So the notebook images that come with the product, they have libraries that we think is useful for you. But if you want to add more, you can always do it from inside your workspace. And then you load the data and like build the model, you train, and then you can actually save the model. So this is when you save the model, it is actually local. It is in the persistent volume that's attached to this workbench. You would still want to move it to the object store, and you can either do it with the code, or you can, if it's a really simple model, you just download it. You can move it to your S3 location. So once that is done, like the next part that comes is like the model serving. So here you can see that you can add your own model servers, like OpenVINO comes with the product, and we've added like runtime, Triton, just as a custom image to show like as a custom model serving environment. So that can also be done here. And similar to the workbenches, you can choose the infrastructure that's required for serving the model. So traditionally, like for like classic machine learning, like you don't need like that expensive resources. But if you're working with large language models, you would still need accelerators like GPUs, and you can pick and choose them. And you can also control like how you want to expose the API. You could make it available through an external route, like add authentication on top of it. But for the example here, I haven't exposed it through an external route, so you would see like an internal route here. So you see here, like I simply deployed the model by just pointing it to the to its location in the object store. That's it. You don't need to do anything else. So once that is done and it's deployed, you would get an API to that model endpoint. And you could, for the purpose of the demo, I can just probably use it in the notebook. So you simply copy and use that in your code.
So I want to point out a couple of things.
Yeah.
So OpenShift AI it's a platform on top of OpenShift, right?
Yeah.
You could almost consider it an application in its own right, in the same way that ACM and ACS are. So I have an OpenShift cluster that has a set of resources. So compute resources, CPU, memory, network, storage resources, PVCs, storage classes, all that other stuff. GPUs, maybe if I'm doing, for my model training, model serving, depending on what I'm doing, all of that. So if I'm just an OpenShift administrator, it's like every other cluster that's out there.
Yeah.
And everything that's happening in OpenShift AI is just workload that's deployed as pods inside of the cluster.
Exactly.
If I'm the OpenShift AI administrator, I don't have to be a data scientist. Right?
Yeah.
Effectively, what I'm doing is helping connect dots, for lack of a better term, around, okay, you need access to maybe a workbench image that has this set of resources inside of it. So, let's create a new image that we can then introduce in here that out of the box automatically has all of the libraries and tools that you need. And you don't have to go into every one of your projects and create a new one. Or, I'm going to provide you with data connections. So, we have this data lake that's on the other end of a wire somewhere. It's a object store. It's a, whatever it happens to be. Making sure that those types of things are available to them, making sure that, as we do the pipelines and, ultimately model serving, the resources at the OpenShift cluster level are available there.
Yeah.
But yeah, it's one of those, like, it took me a little while to realize that OpenShift AI isn't this, completely separate thing that is disjointed and disconnected. It's built on top of. Just like I missaid OpenShift fertilization a moment ago, just like OpenShift fertilization, just like ACM, just like ACS, all of these things that it's still OpenShift. You're just looking at it from a different perspective, and it's limited in scope to the things that persona, in this case, somebody who's doing data science, cares about.
Yeah, exactly. So, I mean, this is where I said, you don't have to think about machine learning as this one-off magic thing happening outside your usual environment. That's why I use the term unified platform, because you don't have to. It's no longer a magic. Everything that you do on top of OpenShift, you can even handle AI machine learning workloads, and you can seamlessly bring that into your application. So here, it's just an endpoint. Now you can, no matter what application you're running on top of OpenShift, you can simply access, send in the data, get the output, and everything is on the same platform.
And like you said, it's just a route. At the OpenShift level, it's just a route to access those.
Yep. And
so, go ahead.
Oh, and the last thing I wanted to show is the pipelines. So, let's see. Yeah, so if you've used OpenShift pipelines, you're probably familiar with the interface, and it allows you to automate whatever I showed you in terms of going through the notebooks. You can just automate the flow completely here. So, and you can
the workbook is for effectively writing. I'll say writing the code that trains the model, and then the pipeline runs that on demand, and then as we see on this one, it does something with it. In this case, it's saving it. I'm assuming it's putting it into an S3 store somewhere.
Yeah, exactly. So in this case, it's a simple workflow. It trains the model, and then it pushes it to your object store. But in reality, you will have the end to end. So
Yeah,
everything's
you would have
automated.
it doing things like going out and maybe refreshing or restarting the model serving service,
Yeah.
so that way it's serving up the newest version and
Yeah.
all kinds of stuff like
Yeah,
that.
exactly.
Okay.
Good.
Well, I think we're bumping up against time. So, again, from the audience perspective, if you have any last minute questions while we close out here, please go ahead and submit those over. Otherwise, again, if you aren't watching us live, if something comes to your mind afterwards, you see the dog poking up here. I made the mistake of petting her a moment ago as she walked by, and now she won't leave me alone. If you're not watching us live, please feel free to reach out, Sully, SULLY, at redhat.com. So this has been, I'll say, educational for me, to say the least. And I say that because I feel like every time I start to get a grasp on, AI, ML, and all that other stuff, it's people have heard me say before, OpenShift is a fractal. Every time you answer a question, it spawns a whole new set of questions. And every time you answer one of those, it's a whole new set of questions, and on and on and on. And
Yeah.
you could say the same thing about OpenShift AI or ACM and ACS and all of the others, right? So this has been interesting and educational to me. In particular, it had never occurred to me that DevOps and MLOps are kind of the same thing, just from different perspectives, right?
Yeah.
And different terminology. So that's really useful. I'm going to start using that in conversations that I have going forward.
Yeah, definitely. Yeah.
With that, I don't know if you have anything else that you want to add, Prasanth.
I'm good. It was a fun conversation, and hope the viewers have learned a few concepts today.
Yeah. Well, thank you for joining us. I really appreciate you taking time out of your day to come on and help teach slow people like me a few things. So thank you to the audience. Again, really appreciate y'all joining us today. Thank you for all of the chat and all the questions that have come in. Don't hesitate to reach out in the future. Pradeep, does the operator provide same capabilities as that of the platform that was showcased? And I think the answer to that is yes. Because maybe because the operator is deployed on top of your OpenShift cluster, right? So it would be whatever the underlying cluster has access to, I think.
Yeah.
Sorry, I shouldn't answer for you, Prasanth.
No, I think the operator is a way you can just install it. So once you install the operator, you should be able to see what I was showing in the demo.
Yep. Okay. All right. Well, thank you very much, everyone. We will see you, or I will see you next week. And I don't know what next week's topic will be, aside from something OpenShift 4.15 related. So have a great rest of your week, and we will see you all later.